So so we are going to talk about capacitors in series. So actually this diagram is about three capacitor joined in series. So here this is capacitor 1, this is capacitor 2, and this is capacitor 3. So um, we are going to learn how can we calculate the capacitance of series, capacitance of capacitor in series. Okay, so here this is the actual mathematics of capacitors, like how capacitors is arranged in series. So 1 by c1, 1 by c2, 1 by c3. All right, so and this is the single capacitor. Okay, so this is the single capacitors, means this is the arrangement of three capacitors in a single capacitors. Okay, so you have to remember one thing, you must have to remember is when the capacitors are in series, then their size be smaller. Okay, their size be smaller, their size be smaller, and their their distance will be larger. Okay, so their distance would be larger. And so here you can see the total capacitance. So actually, so total capacitance means 1 by c equals to 1 by c1 plus 1 by c2 plus 1 by c3. And extra things that you need to remember is that multiple capacitors in series can be viewed in a single capacitor as larger distance, means a larger distance. Okay, so a larger distance, larger distance, and larger distance between the players, and smaller capacitors. So this is the smaller capacitors, smaller capacitors. Okay, so smaller capacitors. um, so here capacitors in parallel. So this is the parallel arrangement of capacitors. Here you can see it. So, and this is the charge aligned here, and this is the complete set of parallel capacitors in one capacitors. So it would result as one capacitors when you arrange overall capacitor in a single capacitors. So this is the numerical calculation of capacitors. And one thing you need to know that in parallel capacitors, the voltage would be equal. Okay, so v1 plus so voltage will be equal in, so there will be equal potential, there will be equal potential but different charge, q1 plus q2 plus q3. So in parallel capacitors, the charge be different, different charge but equal voltage, different charge but equal voltage. Okay, different charge but equal potential difference. And multiple capacitor is connected in parallel can be viewed as a single capacitors. This is a single capacitor, and um, um, a single capacitor with a large area. So it has a large area, so this is the large area. So with the large area, and a larger capacitors, means capacitors would be larger. Okay, so larger capacitors, so larger capacitors. So in series, in series the capacitor will be smaller, but in parallel capacitor will be larger. Okay, so so capacitor since parallel is greater than capacitor in series. So in practical, you can even use parallel capacitors to increase its capacitance. But if you wanted to store minimum charge, then you must have to set up series capacitor, because Capacitors will, because in series the minimum charge will be stored in series capacitor, and it's called as small capacitor too. Okay,